All right, so first of all, it's really weird standing here on the stage and actually having something to say and instead of just presenting people. The talk I'm going to do is called Using Network Automation to Replace Pure Documentation. And it's a talk about auto-generating network documentation. It's also a talk about best practices, but not necessarily in relations to each other. It seems a bit weird, but I'm Allan Eising, if you hadn't catch that so far. I work as a network engineer. I work in Telia company in Norway. I have these 3 AS numbers listed here. The talk here is about the middle AS number, but I'm involved in all 3 of these. I have also a blog where I write something about automation once in a while, a Twitter account, and a GitHub with some unfinished code on it. Starting with a disclaimer here, because I'm going to talk about bad documentation. And I mean, everybody can look up this AS number, and maybe somebody knows somebody who once worked with this AS number. And it's really not my intention to put anybody out there or shame anybody or anything. We who've worked in network operations, we know what time constraints we're working under. We know how hard it is to actually have the time to write proper documentation. And as I'm going to cover later, proper documentation is actually not something that we really do. So with that out of the way. This talk starts with a situation that is common in many larger ISPs and providers, that sometimes we merge with smaller providers, we take over networks, we take with us some engineering staff there, some documentations, and smaller networks have other constraints than bigger networks. They might implement things differently, with less budget, with other standards, or maybe they have more diverse and interesting product portfolio that makes things a bit more custom than we are used to in the big providers. And also there is a culture in big providers that might leave network engineers from smaller providers to say, so long. And then they ride out into the sunset and leave about their documentation. And then you open the documentation and you find a list of resources and some network diagrams. And that might look something like this. Then it might be a list of VLANs, a list of IP addresses. It might be in Excel if you're really unlucky. It might be inconsistently filled out. There's usually about 1.5 standard per engineer when it comes to free text documentation. And network diagrams might have been up to date at the time they were created. But the thing is, nothing here actually tells you about how services look. And that leaves us to a very important observation that resources and services are not the same thing. Resources are just that. They are something we can assign. We can have lists of them. They have life cycles. Resources are, for example, IP addresses, route targets, VLANs, service IDs, whatever we have there. They can come from pools. They can have assignment policies that can say something like, if we provision management addresses, we're going to use this network to take them from, or our management service is always VLAN number 100, or something like that. Policies. Services, on the other hand, include resources. They also include connections between these resources. For example, I might have a link IP address here and a VLAN. They belong together on the same physical link. That's not necessarily so easy to read from the documentation. The services, they own these resources. So we have this relationship between the resources and the services. For example, if I take down these services, these resources are now orphaned and need to be cleaned up. The same goes with services. They are owned usually by a product. For example, I might sell an MPLS VPN, I will call it. That in reality is a VRF I'm pushing out here. So that's the product and the services are not necessarily the same either. And then we have them owned by customers or the infrastructure. So what we are left with here is when we just have the resource documentation, the other is just tribal knowledge. And what do I mean with tribal knowledge? I mean that it's the stories we tell each other and the standards we instruct each other in. These might just exist as collective tribal knowledge. So when you start in a new network engineering department, you are able to say, I have this customer here, he's called Bob, what is it about him? And somebody can say, oh yes, by the way, I remember this customer, he has this and this problem, or this and this policy. But this is tribal knowledge, and we're really, really bad at documenting it. So for this particular network, we lost the network engineering staff there. I had some time with them before they left. I got their documentation. But then I was left also with a platform that I didn't particularly know. Their routers were Nokia routers. I've only really worked with Cisco and Juniper in the past. So I not only had to learn a new network, I had to learn a new platform, and I had to learn how these had services in them. And not only that, I also needed to make sure that my colleagues could do the same thing as me, because they might have had less time than me to learn this stuff. So I wanted to make something that was searchable and documented the services, because searchable is easy if you're really good at, for example, grep commands, and you can grep in the oxidized things, and you get a better picture, but that doesn't really work as something you can let everybody do, and it's not documentation either. So my approach was to write a parser for the Nokia SROS, then write a backend to store it in, write a pretty front end, and hopefully profit from it at some point. So my first step was to start writing this parser. That was difficult. That took a few attempts, and as you can see, this is an actual screenshot from the first directory where I started the work. It took a number of very frustrating attempts, but in the end I came through, and it started off with a lot of if statements and regular expressions and not very, very pretty or readable or maintainable code for that matter. But, you know, in the end I got something that looked a little bit better and was easier to work with. And that was what I based it on. But the takeaways here is probably don't do that. Probably don't write your own parser. There are good ways of writing parsers if you're really, really good at computer science. There are these frameworks to write them in. They're complicated. They're too complicated for me. And in reality, there are much better ways to doing this. For example, if you have a modern network operating system, you might have Yang models. Yang models are really cool. They're model services and network configuration, and then that saves you the whole parsing thing. If you can't do that, we have things like text FSM, which is a cool way to parse CLI output. Or if you have a Junos device, you can just pipe display JSON or display XML, and you also have everything structured for you. And I'm sure that iOS XR has the same thing. Once I had something parsed, I needed to store it somewhere. And the logical place to store something is something like an inventory, which is basically just a number of SQL databases. But I decided to write this in Django, which is relatively popular these days. So it's easy to get started with, it's easy to write, and it has a really cool thing. It has a database ORM. A lot of systems like this has it, but that gives you the one advantage that you can make mistakes. And you will make a lot of mistakes if you do things like this from the bottom up. For example, a good example of a mistake you could have made, you could have looked at the configuration and you could have made the conclusion that all my route target import and exports are the same. So why use two different database fields to store this? I can just collapse them. And then you find that one that has the different. So you decide to change this, and this is very easy. You don't need to know any SQL to do this. You can just change things, and Django will help you do the migrations. And then you can. Then another cool thing about Django is the REST framework. That is something that allows you to really easily make APIs for this. And APIs is really essential, I think, if you're going to do any sort of storage of services and data and network information. There are lots of alternatives to Django, and it's really what you feel is the tool for the job and the tool that you can do. There is probably a Django-like system for every programming language that has a reasonable amount of popularity these days. Django is Python. There are other frameworks in Python as well. But this worked really well for me. I had some lessons when I did this, because I'm used to when I do my databases, I put in an ID in every table. It's not necessary to do that. And it's really nice to use natural keys when you can do it. For example, in your network, your host should be unique. If you have two routers called exactly the same, then you have another problem. So your hostname can be your key, and that makes updating really a lot easier. You should also be aware of human input errors. This comes back to the whole writing a parser thing, because white spaces can exist whenever you do anything inside of string. And that is something that can happen on this Nokia SROS platform a lot, because interfaces, for example, logical interfaces, are just something you write within two of these nice exclamation, these quotes here, quotation marks. And that means you could put in whatever you want, including white spaces at the end. And that is something that's going to mess your regular expressions up if you don't catch this. Also, things that should be unique but aren't. It's possible to have two interfaces called exactly the same if one is actually active and the other one is not configured correctly or in shutdown or not attached to a physical interface. And that's also something that's really hard to do in a line-by-line parser, because then you come into sort of these conditions where you override a running interface with something that was shut down because the VRF is numerically lower down in the configuration. Really, really hard to solve. The easy way to solve it is, of course, clean up your network, but that's not always something you can be 100% certain happens before you run the parser. So I started this, and it sounds like a lot of complicated work, but I did this in stages, and the first stage was already 100% usable, because it was just a matter of taking a manual configuration file from the router, putting it into the parser, and directly populating it into the database. And whenever I had to update this, I just deleted the node and re-imported it again. So I didn't have to take care of updating any objects. I just started from scratch every time. And it's quite easy to have something. I mean, if the goal is just you need to be able to search for a description, well, that's a few lines of Python. That's really easy. Services, it's also easy to index services. It doesn't have to be very complicated. So the next stage of the development was to have this a little bit more automatic. I needed configuration backup. Everybody does that. We use Oxidized for this. So I plugged in Oxidized, and Oxidized has a REST API, so you can just go in and see which nodes are in Oxidized, give me the configuration, it works. Still, the parser runs inside the Django application. Everything is inside of this application. Then I got the crazy idea to rewrite the front end. But I think that's something you can do and should do if your goal is to have something that is very easy and very fluent to work with. And I wanted to take the view out and have it as an external component, both because I wanted to write an IPAM that I won't talk any more about because that didn't work very well. But having it external allowed me to have a much more smooth UI experience, and it forced me to write the API. And now the architecture looks like this, and it's actually pretty cool now. I have the front end completely separate. I have the synchronization engine completely separate, and it listens to Oxidize and checks whether a node has changed, and it just synchronizes those changes. And the Django application is now just an API. So this comes back to something that struck me when I listened to the talk, the other automation talk from Webcom, is that these are two completely different ways of handling the source of truth for your network. In this picture here, I don't trust my documentation. I want to use the network as a source of truth. You can do the other thing, but then you have to be very, very certain that everything that is in your documentation is always correct. And you need to be prepared to override your network completely with your documentation. I don't think many networks are at that point. I congratulate every network that is. In this case, it absolutely wasn't. So it's not a provisioning system. It maybe can be that at some point, but it's an excellent reference that can be used to show what is in the source of truth. It's impossible to do demos here, unfortunately, but I've put out the tool on the internet. It's loaded up with bogus example data and using only like a quarter of the functionality in there. So, but you're absolutely welcome to type this into your browser and toy around with it. There's no customer sensitive data in it whatsoever because everything is generated for this. And I will probably take it down tomorrow or the day after. So the front end looks like this. It's quite clean. It uses Google's material design framework. It has very few functionalities. It has nodes, VRFs, layer 2 VPNs, and the IPAM that we won't talk about. So it's written in something called Vue, which is a JavaScript framework. I'm using pre-made UI components. That makes it super easy to do these styling things. It interacts with the backend through REST. The thing about using a JavaScript framework and using these UI components means that I can be 100% certain that it will load on my phone as well. Not that this isn't necessarily a target, but it's much more flexible. It has an overview of each node. You can click into a node and you can see the ports, lags, interfaces, routing information, and drill down on that as well. You can see what services are in the network. And when you click on a service, you get a nice diagram. And that was one of the goals of the system, to be able to generate this diagram. It might seem like a trivial thing, but being able to go to a network you don't know, you need to look up this customer because this customer has created a ticket or called in. Then you go and you search for the customer, you find his VRF, you get a diagram of how he's connected. That has a lot of value for anybody who's working in operations here. The diagrams are ordered with a box per site. It's the router and their interface. I'm using a library called Dagger D3. It wasn't terribly complicated to write. I was pleasantly surprised. You can drill down to PTP configs, for example, see the prefix lists and the policies, both on a per group and a per peer level. It gets a little bit more complicated when we come to layer 2 VPNs, because layer 2 VPNs can have really strange and intricate connectivity scenarios with their pseudo wires together. Especially if it's not a full mesh of pseudo wires, then the diagrams will be extremely hard to read. But you can zoom and do stuff that makes it a little bit easier. And I really think that this is a level that I would assign as good enough. There's always ways you can improve these things, but this is good enough for an operational day-to-day job. And searching. Searching is also key here. I need to be able to look up an IP address if a customer complains. And I can also type in whatever text description I want to search for. But one of the cool things I can do is I can pull up a report of a supernet and see which individual addresses are in use in the network. So in this example, it's not as interesting to look at because I've just filled in example data, so it's very uniform. But if I type in whatever supernet I want to search for, I get a report of all the resources that are configured this. Obviously, it's not live data. It's only like interface addresses, prefix lists, and static routes. I'm not pulling any route tables from the routers at the moment. So again, you don't have to do it this way. You don't have to have a GUI as a standalone thing. It's become relatively easy code base to maintain because I have. Oh.
You are getting compliments for being good at standing still and being quiet.
Shit. That's not often that happens.
And I have a whole bunch of questions lined up for you
Oh,
for when you're done.
Yeah. Can we get a confirmation on whether the stream works at all?
Stream works fine. Can you please move?
Okay.
Yes.
Good. No, I had this this night job where I had to change the MTU of a port and then go through all the VRFs configured in that port, which was a lot, and specify the IP MTU of every sub interface there. And that could be achieved with this few lines of code. And that's one of the key things here, that if you collect data about your network, make it available, because this is operational information that everybody in operations are going to appreciate and will be extremely useful in any sort of migrational or change scenario. So, jumping to conclusions here. It is possible to create service documentation automatically. At least I think that was achieved here. It can be done a lot simpler than I've done here. But as I said with the individual phases I went through, you don't have to wait until you have this mega modular application. You can start simple and have something that works. So this tool has become extremely useful, and I can't open source anything right now, but I'm working on doing that because I think a lot of this is extremely handy. There are some things that has a lot of assumptions on how your network looks, but I mean the parser is cool. The synchronization engine I've written that takes a Python object and synchronizes toward a foreign REST service is also pretty cool. Maybe somebody can also teach me to be better at stuff. So I hope I haven't rushed too much through this. I haven't checked the clock, so I don't know how much time I've spent. But absolutely take some questions. That's a record.
Cool, because there are some questions. Starting with the first one from Martin Willems Christiansen. Question: if it becomes a provisioning system, wouldn't it then become the source of truth instead of the network?
Yeah, that's an interesting point. No, no is the short answer, because the part that will be needed for just basic provisioning is just number assignment here. And number assignment is still just resource documentation, and it's not necessarily enough to define the whole network. It's only a source of truth if you can regenerate the whole network configuration from it. You can still have a network provisioning system that is not the truth, the source of truth for your network.
Okay, next one from Jan Krillesen. Did you at some point consider using SNMP for obtaining the configuration services from the router instead of parsing the config?
No, and there's a really good reason for that. The first versions did not have access to the routers. I had to go to one jump server, load in the configuration by hand, and then paste it over to the system. So parsing was the only option I had in the beginning.
Final question from Veit. Question: do you plan on adding more parsers, information providers? Generally, is extensibility a goal, or is this intended as a specialized tool for your use case?
It's not intended as being platform specific. And that's one of the reasons that I took out the synchronization engine. Let's see if I can find that. Yeah. So the sync application here uses my parser as a third-party package. And the object structure is not very foreign when you look at it compared to the network. So it's absolutely possible to use any other tool for that. And one of my early versions actually had an integration with Cisco NSO as well. So it is entirely possible to do whatever there.
Yes, I have a final question. Christian here. You have 11 minutes left. Can we please hear more how embarrassingly wrong and how it failed your IPAM system?
It's not as bad as I made it sound here. It's just not very finished. That's the thing about it. The whole thing about Maybe I can actually, because no, I probably wouldn't want to do that. The thing about the IPAMs part is that that was the one that triggered the rewrite, and you can probably click around in the IPAM. It should sort of work, but it triggered the rewrite because this Viewtify diagram that or Viewtify framework that I'm using has a tree view that allows for asynchronous loading, which is really handy because the network I took over here had an IPAM that was thousands of lines in Excel. So I needed a way to structure this somehow and wrap it in. And if I loaded it, if I generated the whole tree in Django templates, my browser would crash. So I needed a way to be able to have a recursive tree lookup that would just print the subnet I was clicking on. And that was the reason I rewrote it in this JavaScript frontend. And that succeeded, but it's just unfinished. That's basically it. I need pool functionality. I need consistent adding of subnets and stuff like that. And it's not really working right now, but in the future.
Okay, thanks. Looking forward for the 2.0 version next year.
Sure. All right. Thank you very much.